In this session, we are going to learn about the plastics. What are the types of plastics available, and their ranges of plastic, and their applications in both the engineering industries and in common usage. So, let us move to this topic. Plastic may be defined as an organic polymer which can be molded into any desired shape and size with the help of heat, pressure, or both. That is, by the help of heat, pressure, or by application of heat and pressure, we can mold into a desired shape and size. So that is plastic, and it has its wide application because of its property like low price, color ranges, toughness, water resistance, low electrical and thermal conductivity, and ease of fabrication. Generally, the plastics are available in powder form, sheet, films, rods, tubes, and liquids. The comparative study about the natural plastic and versus synthetic plastics are done here, and similarly between natural polymers and synthetic polymers are done. So, first, natural plastics are occurring naturally. Examples of it are resins, lac, and casein, and synthetic plastic prepared artificially. Examples include urea, phenol formaldehyde, polystyrene, and acrylic. And compare natural polymer with synthetic polymer, which polymers that are obtained naturally from animals or plants called natural polymer, and which is chemically prepared by human or called as synthetic polymer. Some of the example of natural polymers are the starch, natural rubber, cellulose, cotton, wool, etc. And the synthetic polymer examples are polyethylene, polypropylene, Teflon, and polyvinyl chloride. So, some of the raw materials sources for plastics are animal and plant byproducts such as casein and cellulose and wood pulp. Coal byproducts, petroleum byproducts are acting as a raw material for source for plastics. And gender classification of plastics are of there are two types. One is thermoset, another one is thermoplast. And if you look at this diagram, it is understood that in thermoplast there is no cross link similar to thermoset. This cross link is nothing but an intermediate bond between these nearest chain atoms, and this represented as a black color circle, and which represents a cross link. So thermoplastic doesn't have any cross linking between their chains, whereas thermoset have the cross link between their chains. So if we compare this, due to that property, the intermolecular forces between the chains are relatively weak, and thermoset, because of this cross-linking property, they have a stronger chains. And some of the example of thermoplastics are polyethylene and nylon, and thermoset plastic examples are bakelite. Some classification of plastic based on the arrangement of resin, that is thermoplastic resins or thermosetting plastics. If you look at this two picture, it is understood that in thermoplastic it is prepared by addition polymerization. It is here it is prepared by condensation polymerization. It consists of linear long chain polymers. It consists of three-dimensional network structure, both linear and non-linear structures are there, and they are soft, weak, and less brittle. They are hard, strong, and more brittle. Some of the classification of plastics again picturized here. And if you focus on thermoplastic, commonly called as thermoplastic, also known as thermoplast, or a plastics whose plasticity with the increase in temperature. It means that thermoplastics soften when heated and hardened when cooled. Thermoplastics may be solidified and reheated as many times as desired. Thermoplastics are relatively soft and ductile. Thermoplastic mechanisms are formed by addition polymerization, by linear polymers mechanically deformed and softened at high temperatures, and it can be easily molded due to the absence of crosslinks. Examples of this thermoplastic I already mentioned: polythene, polystyrene, polyamides, polyvinyls, acryls, etc. And thermoset plastics, thermosetting plastics, commonly called thermosets, are plastics which become permanently hard when heat is applied and do not soften upon subsequent heating. That is, thermosetting plastic once set cannot be softened on heating. They cannot be remolded, reshaped again and again. That's why they do not resell or scrap value. The thermosetting plastics are generally stronger, harder, more brittle, more resistant to heat and solvent than thermoplastics. Some of the examples of thermoset plastics are polyester, phenol, urea formaldehyde and epoxides. Then both the thermoset and thermoplast are again classified based on the usage, uh, that is commodity plastics and engineering plastics. Commodity plastics, the widely used plastics are called commodity plastics. Commodities generally have lower cost. Most commodity plastics are used for throwaway items such as hot or cool drink cups, plastic bags, boxes, etc. And based on the usage, commodity plastics are categorized into thermoplastic, thermosetting, and thermoplastics are polyethylene, polypropylene, polystyrene, and polyvinyl chlorides. And some of the thermosetting plastics commonly used are phenolics, unsaturated polyesters, ureas. And based on the usage in industry, it is called engineering plastics, and due to their higher strength, greater environmental resistance, and better physical properties, again, the engineering plastics are categorized. Thermoplastics and thermosetting plastics are listed here. Some of the examples are listed here, like ethnic, polyamide, cellulose, acetals, polycarbonate, etc. are under thermoplastics. And under thermosetting plastics, silicones, polyamides, urethanes, melamides, and epoxides are listed below thermosetting plastics.